subtracting rational expressions, much like multiplying and dividing and simplifying, you learned the basics of it back in elementary school. Can you put the laptop away, please? Thank you. With problems like this one. How do we add and subtract fractions? Make the denominators the same. We need a common denominator. Most often we want the least common denominator. When it's just regular fractions, any common denominator will do. But I'm going to tell you right now, LCD is going to be the best as we get into this chapter. So, what is the least common denominator between 12 and 9? Three is the greatest common factor, not the least common denominator. Least common denominator is the smallest thing that I can turn them both into via multiplication. Those are my multiples of 9. These are my multiples of 12. Smallest one they have in common, 36. They can both become 36. How do I turn 12 into 36? What do I multiply by? 3. What about 9? 4. And if you multiply one side of the fraction, you have to multiply the other side of the fraction. Why? Why, if I multiply the bottom by 3, do I have to multiply the top by 3? Then it's still the same fraction. I can't change the fractions just because I don't like that they don't have a common denominator. They have to be the same fraction. How do you make sure you have the same fraction? You multiply by what number doesn't change anything? 1. Multiplying both the top and the bottom by 3 is like multiplying by 3 over 3. And 3 over 3 is 1. Multiplying top and bottom by the same thing, always 1. That's why we're allowed to do it. That's why we have to do it. Because we can't change the fractions. We can make them look different, but we can't actually change how big or how small the fractions themselves are. So I end up getting 15 over 36 plus 8 over 36. Now what? Add the numerator at the top. 15 plus 8 is 23. What about the bottom?
36.
Keep it, 36. When adding fractions, you get that common denominator. That way, essentially what you're doing with the fraction is you are making it where this 5/12, instead of being an object broken up into 12 parts in which you have 5 of them, you're taking that object, breaking it up into 36 parts, and the other object breaking it up into 36 parts and saying, okay, I've got 15 of this from this one, 8 from this one, which means 23 parts, all of the original whole that was broken up into 36 total parts. That's what you're doing when you're adding fractions, is you're just kind of getting that common denominator, is getting it where the whole is broken up into the same number of pieces, so they're all the same size pieces. And we ended up with 23 of those pieces. Now, the key thing in adding and subtracting fractions is that common denominator. It's really the piece that people miss. It's also the piece that is the hardest to find typically. Y'all had no problem whatsoever, 15 plus 8. Okay, maybe it's a couple of you were like pausing to figure it out. But for the most part, I have zero doubt in my mind y'all can get 15 plus 8. It's figuring out that common denominator that was the struggle. Now, when it was just plain numbers, you had the advantage of being able to do what I did on the board, where you just list off the multiples, because eventually you'll find the common multiple. But in general, when it comes to rational expressions, doing this doesn't work so much. Because with numbers, you knew you could only multiply by numbers. We weren't all of a sudden going to say, okay, I've got a multiple of 9. Well, 9x is a multiple of 9. So is 9 times x plus 2. Like, there's way too many things that I can multiply by 9 and have it be a polynomial. When it was just plain numbers, you were just multiplying by numbers. When it's rationals, the variables getting involved, the fact that it could be binomials, trinomials, quadrinomials, etc., it becomes too much. So we need a different tactic to find our least common denominator. Now, another way that you would have found least common denominators back in elementary school, or LCDs, is you would have taken your denominators and broken them down into their smallest prime factors. So 12, to start things off, can be written as what times what? 3 times 4, I heard, which is a fact. Which of those is prime? Prime means it can't be divided by anything else. The 3 is prime, so that part's good, but 4 can be broken down into 2 times 2. Both of those are prime because they can't be divided by anything but 1 and themselves. So, 12 as its prime factorization, that's what it's called when you break it down into all things that are prime getting multiplied, is 3 times 2 times 2. Okay, we do the same thing with 9. 3 times 3. Does that one break down any further? No. So then we take these two lists, which I like having them lined up, so I'm just gonna, for no particular reason, do this. We look for what they have in common. They have a 3 in common. That is their greatest common factor, is that 3. And that greatest common factor in the LCD doesn't need to be put into the LCD more than once. It just has to be put in there once, those things that they have in common. And then everything they don't have in common also needs to be a part of the LCD. What they don't have in common is a 2, and an additional 3. So that means 3 times 2 times 2 times 3 is my least common denominator. And 3 times 2 times 2 times 3 is 36. Now, this can be a pain in the butt to do with numbers. And it doesn't always seem worth it if you know your factors and your multiples of numbers. Some of you, I know I wrote this up here, but there was probably at least some people in my FST class here or my other one that would have been 9 and 12. They both go into 36, so it must be 36. There's always some people that know the multiples well enough. And maybe you didn't know it for these two, but I have zero doubt in my mind if I asked you, what is the least common denominator of 6 and 5? What would you probably tell me? 30. Some numbers you could probably come up with. But this process is still the same process we do with rationals if it's not obvious what the LCD is. Though I don't tend to do it quite this formally. Okay. So, first things first. Let's find our least common denominator on a couple of problems just to make sure that piece we got a little extra practice on. Because like I said, that's the piece that messes with people the most. Three over 8x squared and 15 minus 3x over 6x. Now to do this, you can break down your denominators into their prime factorization if you want. At the same time, you don't have to. The key thing about me showing you this is to find the least common denominator is based on it in its factored form. That's the key thing. You can't find it unless it's factored. Can I factor 8x squared? No, it's got no addition or subtraction. Can I do a prime factorization? Yes. Can I do like a factoring? No. How about 6x? No, can't factor either of them. So I need to find the smallest thing they both multiply into. If I want, I can list out that prime factorization, look what they have in common, or I can just work with this in pieces as well and say, okay, I'm going to start with my numbers. Because numbers multiply by numbers to get other numbers. 8 and 6. What is their least common multiple? In other words, the smallest thing they both multiply into. 24. They can both become a 24. So, LCD is going to have a 24 for the numbers. What about x squared and x? Smallest thing they can both become? When it's just variables, it's x to its biggest power that's there. Squared. Because I can multiply by x by x to get x squared. Now, this isn't a part of the question, but I always ask it every year. What would you multiply this one by to get it? What do you multiply by 8x squared to get 24x squared? 3. What about this one? 4x. And if you multiply the bottom of the fraction, you also have to do what? Multiply the top of the fraction, because technically you're multiplying by a fancy version of 1. 6 plus x over 10xy and 14 over 7xy squared z. Least common denominator. Is there addition or subtraction in the denominators that I need to factor? No. Which means I'm just going through and saying, okay, what do I have to multiply to get them, or what do they multiply and become if I want them to be their smallest? I phrased that weird. Y'all know what I mean, I think. 10 and 7. 70. If they don't have any greatest common factor, then the least common multiple of them is just them multiplied. 10 and 7 do not divide by the same thing. Therefore, the smallest thing they become is 10 times 7. Okay, I see they both have an x in the denominator, which means my least common denominator does need to have x to what power? Just 1. They both have y's in the denominator. Y squared. This one has a z. I need a z. When it's monomials in the denominator, it's not so too bad. And I'm going to ask this question again. What would I multiply the first one by then? I heard 7. Good. YZ. 7 to get the 70. It's already got the x. I've got a y. I need a y squared. And it needs a z. What about that one? 10? No variables? No. It's already got the x. It's already got the y squared. It's already got the z. One more for you. And then we're going to move on to actually starting to add and subtract them. It is possible, and there will be times where you need to add and subtract more than just 2. When you have more than 2, this is where sometimes you might want to start writing out the factorization, but you don't have to. I generally don't. I generally say, okay, look at 2 of them and say, okay, if I got a 4 and a 3, the smallest thing they multiply into is 12. And then I look at the other number, and first I ask, would that multiply into 12? Yes. If it doesn't, then I look for the least common multiple of the 12 and whatever's number's here. But in this case, they can all become 12. What do I need for variables? X to the third and y to the second. What would you multiply the first one by? 3x squared y squared. Second one? 4x cubed. Third one? 2y. And again, if I multiply the bottom of a fraction, multiply the top. Because when I'm adding and subtracting, I can't change the fractions. Okay. Now that we've got that. Let's get into the actual adding and subtracting. Now, I'm going to emphasize the fact that notice my instructions say simplify. My instructions will say simplify a lot. My instructions will say simplify if I give you a single rational expression and just want you to simplify it. It'll say simplify if I multiply two rational expressions and expect you to multiply then simplify. Same thing with divide, same thing with add, same thing with subtract. Every single one of these is a simplify operation. So that means you need to pay attention to the operation between the rational expressions, because one of the hardest things about Chapter 8 is not the individual tasks. It's not the multiplying, the dividing, the adding, the subtracting. It's when they all get mixed together, do you know which process you're doing? That's what messes with people with Chapter 8 more than anything else. That and don't mix it up with solving. But we'll get there. That's a ways from now. We're going to start off nice and easy. When you start the process, of simplifying, check that operation. Adding. When adding, do we need the common denominator? Yes, I asked that because with multiply and divide, we don't need it. And in fact, you'll make life harder if you do it with it. It still works. It's just going to have to simplify a lot more later. Okay, we need a common denominator, and do you notice they have one? Okay, so we add the numerator, we keep the denominator by itself. One of the things you're going to find me doing is, regardless of what the numerator is, I will almost always just write them out with a plus sign between them and put them over the common denominator, whether things go together or not. I do that for a reason, because one of the things, especially when we get to subtract, is people tend to make some mistakes that are like crucial in changing the problem if you make that mistake. One of the mistakes I commonly see, and the reason I start with this problem, is people see 2 plus 13x and they write 15x. It's 2 plus 13x, 15x. No, be careful with your like terms. They do not combine. After you add, you have to simplify. Can I simplify this? No. To simplify it, since I see a plus sign, I would have to factor. 2 plus 13x doesn't factor, which means that's stuck in parentheses, and the 15x can't simplify with it. Said I was going to start off simple. But I want to address some of the common things I see. That's why I start off simple. When subtracting, do I need a common denominator? Yes. But I already have one again, right? Okay. A problem like this, as simple as it might look for some people, is one of the biggest causes of mistakes, little mistakes that I see. Because the first thing people do, even if they follow what I did, is they write this. hate to break it to you, that's not right. What did I screw up? When I'm subtracting this entire fraction, therefore this needs to be in parentheses. I need to distribute that negative. Continue to simplify. I've got some like terms. Generally speaking, I put things in standard form, so I go with my x's first, and then I go to my numbers. If you chose to write it as 5 minus x, it's equivalent, but there's a reason I do this. Okay. Can I simplify it? No, I could try factoring that numerator. All I would get out of it is a negative. Negative, parentheses, x minus 5, over 22xy squared. The only way monomial simplifies with other monomials, which means the only way this 22xy squared is going to simplify is if I get a greatest common factor out of the top that simplifies with it. So, it doesn't simplify. If you did factor out that negative, I'd be perfectly okay with that if you left it that way. Okay, let's step it up a little bit. I'm adding, so I need a common denominator. This is the time they don't have it. X and 3x squared. What is my least common denominator? 3x squared. So, don't have it, have to multiply things on both top and the bottom of the fraction. First fraction multiplies by 3x. Second fraction multiplies by, technically, do I need to multiply anything? If I am multiplying, what number am I multiplying by? 1. Okay, 3x times 2. 6x, 3x times x. Hopefully it's 3x squared. If it's not, I've got a problem. Plus 9 over 3x squared. Get the common denominator, add the numerator. 3, I don't know why I ever said 3. 6x plus 9 over common denominator, 3x squared. Can I simplify? Yes, the top factors, I can factor a 3 out of it. Leaves me with 2x plus 3 all over 3x squared. What simplifies? The 3 and the 3. That 3 specifically in that one. 2x plus 3 over x squared. Now, just a quick note. Did anyone notice something we could have done at the very beginning? Could I have simplified my original fractions? Yes. And had I done so, that 9 over 3x specifically, that would have been a 3. That would have gone away. My new least common denominator would have just been x squared, so I wouldn't have had to multiply by the 3 here. And I would have ended up getting 2x over x squared plus 3 over x squared, and therefore would have gotten 2x plus 3 over x squared, which is the same as what we got. If you can simplify the fractions at the beginning, you're welcome to. A lot of the times it will help out, But I'm going to tell you right now, sometimes it might not. It might not. Because you might actually be moving away from having an easier least common denominator. So I don't tend to do it unless I see that it's going to help. That's why I didn't do it first here. You're welcome to do it. You don't have to do it. Another very common error comes out of this next one. What should we do first? Okay. There's a couple different ways to start this one. I heard LCD, so let's go for it. 5a cubed b squared and 10abc. Smallest thing they both can become? 12. Okay. 10. A cubed, B squared, C. What am I multiplying by the first one? 2C. Second one? A squared B. What's getting multiplied by 2c in that numerator? The 4, the 3c, or both? They're both in the fraction, right? Remember, when there's addition or subtraction in a fraction, it's technically grouping. And yes, you have to distribute then. 8c plus 6c squared over 10a cubed b squared c minus. This one didn't have addition or subtraction in it, so 8a squared bc over 10a cubed b squared c. Have the common denominator, so now I can subtract. 8c plus 6c squared minus 8a squared bc all over 10a cubed b squared c. Can we simplify it? If you can combine like terms, do it. There aren't any. Can we factor the numerator? It's ugly, but you can always try what kind of factoring? Greatest common factor always works on every polynomial out there. Okay, if there's something other than one. All three of these divide by 2c. 4 plus 3c minus 4a squared b all over 10a cubed b squared c. Two and the 10 become a 5 in the denominator, and the c's cancel out. So I am left with, okay, I can leave it in that order, but it bugs me that it's not in standard form, so I'm going to reorder it. all over 5a cubed b squared. This is another one that I could have simplified at the very beginning. Would that have made it easier? Specifically, the second fraction simplifies. If I had simplified the 8 and the 10, I would have had 4 over 5. Hey, my 5s would have all of a sudden matched. That would have gotten it easier. The c's would have canceled out. This one didn't have any c's. It would have actually helped out, but it doesn't always. How you know it helps out is if it gets it closer to looking like the other denominator. Okay. I've got 2 more examples that show some of the biggest mistakes, and then we're done. Because one of the things you probably noticed is so far none of our denominators have had addition or subtraction. And that was done on purpose. For the most part, today, as we're adding and subtracting, our denominators are going to be monomials, or they're going to be very particular binomials that I chose. For example, common denominator binomials. Since they already have a common denominator, I subtract. And I combine my like terms. Being careful of what?
Are we not distributing the minus anymore?
I was about to say, is what I wrote down correct? No, it's not. If you are subtracting something that has addition or subtraction in it, in that numerator, it needs to go in parentheses. You need to distribute that negative. If you haven't figured out by now, sometimes I do that on purpose. Combine my like terms, I get a negative x and a positive 3 over an x minus 3. Can I simplify that? Heard someone say yes. What do you notice about those 2 terms? They're exact opposites. Negative x, positive 3, negative 3. And when they're opposites, you can cross them off as long as you put what in front? Negative symbol. What's the negative going in front of? 1, not 0. The only other situation where you're going to see a binomial in the denominator today is this situation, where those binomials are much like the previous one, we got opposites. Positive m, negative m, positive 12, negative 12 between the 2. Now, I can't just start crossing them off. We're not simplifying at this point. But if they're opposites, that means I can put a negative in front of things. Generally speaking, when you're doing this, in the denominator especially, they want the leading coefficient to be positive. And the leading coefficient is the coefficient of the term with the biggest exponent, and in this case it's m, because it's got an m to the first power. The number technically has an m to the 0th power on it, it's a smaller exponent. So they want the m to be positive, which means the first fraction, we want to change that one to looking like that one. to do that, we're going to essentially follow the idea of what we do with opposites. Opposites, the only difference about them is one is a negative version of the other. So when you come across that, I can change this denominator into m minus 12 if I put a negative in front of the fraction. Which gives me my common denominator to subtract. If you put a negative in front of the fraction, in all technicality, that negative goes to the top of it. So when I go to subtract these, not only do I need to put the parentheses around the negative m minus 3 that's on the right fraction, but I need to put a negative on that 6. So far, I'm just combining like terms because you all know how to do that. Can I simplify? To simplify, since they have pluses and minuses, I would need it factored. M minus 3 does not factor, so technically it goes in parentheses. Neither does m minus 12, and I can't touch parentheses unless they match perfectly with the other ones.